Well, now that we have Bolzano's theorem and modified Bolzano's theorem under our belts, now we can look at the intermediate value theorem, which you probably remember from calculus. Theorem 316. I'll sometimes refer to the intermediate value theorem in proofs just with IVT. And it says this: if f is a function from a into the real numbers, and if f is continuous with a connected set, so basically it looks like an interval, and we take a and b as being elements of the domain, capital A, and a being less than b, we get the following. If the value of the function at a is less than this number y, which is less than the value of the function at b, again, you can think of this y as being the in between the height of the function at a and b, or the reverse of that, we have f of a being the larger, and then y, and then f of b. If that's the case, then there is some c in between a and b where f of c is equal to that value of y. So before we go through the proof, which is just 4 or 5 sentences, I believe, let's draw a real simple example of what we're talking about. Maybe I will do just a straight line. And let's say that a is here and b is here. Here's f of a, f of b. So what that's saying is that if I take any number y that's strictly in between these two values, like for example there, somewhere close to the middle, call that y. Well, here is the number c that would satisfy the theorem. F of c is equal to that y. Real simple example, but the way we're going to prove it, let me just draw a picture so we'll know where we're going. Y is simply a number. And what I'm going to do is create a new function where I'm going to take, this is f of x. I'm going to do f of x and then subtract the number y, which all that's going to do is lower it by y units. So y is this big. So let's see. So if I lower it, maybe I'll use a different color here. This would be the function f of x minus y, minus some number. So it's just a new function. We just dropped it down by y units. Well, notice where that crosses the x-axis. Exactly at c. So you might guess that we're going to use modified Bolzano's theorem where we're looking for a zero of a function. We're going to take this function, drop it down by y, find the zero, and wherever that zero is, means that's the same x value where f of that number is equal to y. So let's take a look at the proof. Okay, well, we have two possible values for the number y being in between f of a and f of b. We're going to assume this one. If we chose this one, the proof would be very, very similar. So we're just going to prove it for this case here. Assume f of a is less than y, which is less than f of b. And therefore, what do we get? I would like to have 0 in the middle, so I'm going to subtract y from all three sections. F of a minus y less than 0, less than f of b minus y. And if you'll notice, this new function, which I haven't actually defined yet, this is a continuous function, this is a continuous function because it's a continuous function minus a number, which is also a continuous function. So now let's define what I'll call g of x. Let g, which has the same domain, let this function be defined like this. G of x is equal to f of x minus y. So this would be g of A, and this would be g of B. And as I mentioned already, g is continuous here because it's the difference of two continuous functions. Thus, we get g of A less than 0 less than g of B. That's reasoning. That's just substitution. I'd already mentioned. This is just g of A, and that is just g of B. All right, so maybe I'll add on one more sentence here. So, what does that tell you? If one is to the left of 0, one is to the right of 0, that means they have opposite signs. So, g of A and g of B have opposite signs. One of them is positive, one of them is negative. Thus, excuse me, thus, there exists a C strictly in between A and B, such that g of C is equal to 0. That's by Theorem 315. I'll squeeze it in right here. Theorem 3.15, the modified Bolzono's theorem. But that means that, g of C equaling 0, g of C equaling 0 implies what? Well, g of C would be f of C minus y. Because this is just g of C. And we're just about done. That implies that f of C has the value of y. The height on the graph would be y. And that's the end of the proof.